All right. So we want to now take iUserUtility and implement it in SQL user utility. So jumping back into our solution, we'll go to the SQL user utility class. And this is where it's nice using Visual Studio, is that we can come over here, we can do colon, iUserUtility. Well, first of all, we don't have a using statement in this project. We actually don't even have a reference. So let me go back and right-click on references, add reference. And I'm going to reference that core project so that I can then bring in the interface. So once I've done that, I still need to add the using statement for the core. And then once I do that, I am now saying that this class implements this interface. I was really hoping it was going to give me a red underline. So if I attempt to build right now, I'm going to get 4 compile time exceptions. The first exception says that SQL user utility does not implement the interface member get all users. Second one basically says the same thing about update users. Third one, same thing about delete users. And the fourth one says the same thing about add users. Any guesses as to why?
Since it's using the interface, it has to implement all the methods that are defined.
Correct. So that's the purpose of the interface definition, is that you actually have to implement, you actually have to have public members that provide the body to those methods or properties. And that's the whole point of the interface, is that the interface says this is what this class has to have. These public members have to exist, and they have to be implemented. And without the implementation, you get a compile time error. Because if I'm that third user in that use case where I said I'm using a class and I'm using an interface, and you didn't actually implement the interface correctly, you've now broken my code. Because I'm assuming that that function or that property exists because it's part of the interface. And if you, as the person writing the class, didn't actually implement the interface, or a more common case is that you implemented an old version of the interface, my code is now broken because I'm going to call on a function that doesn't exist. So to implement the interface, you can go through and hand code all those method definitions. Or within Visual Studio, we get an accelerator. And it'll ask you if you want to implement the interface, iUserUtility, or it gives you a second option that says, do you want to explicitly implement the interface? We're going to choose the first option in almost all cases. The only time you would choose to explicitly implement an interface is when you did not want to have that public member as part of your class, but you wanted to provide the functionality that that interface defines. You may be thinking, okay, what does that mean? Is that what you're thinking? Good, that means I'm teaching you the right way. You're thinking the way I want you to think. Example, if you had an object that was a collection of something, there's an interface called IEnumerable. IEnumerable is the interface definition that the for each loop uses, that allows you to do for each object in the collection. That functionality is there to allow you to do for each loops. That interface is actually there so that you can build a collection that is able to be used in a for each loop. Without implementing IEnumerable, you can't take a collection, even if it has indices and all those other pieces. Without IEnumerable, you can't write it into a for each loop. Now, along with the ride, you also have all these additional methods that you have to implement as part of IEnumerable. And maybe you feel like they dirty up your class, because you have all these methods that are there and they don't really serve any purpose in your use case because you created this special class that is a collection of orders, or maybe it's a collection of items in a shopping cart, and you really don't want all these other classes there. Or even better, maybe you have a method that has the same name as one of the methods out of the interface. And it serves a completely different purpose than the method definition that's needed to implement that for each loop. So instead of doing just a standard implementation, you would explicitly implement IEnumerable. And what happens then is that it'll actually say IEnumerable dot function name parameters, and it'll give you a function body or definition with that layout. And I'm going to actually do it so you can see it. And then I'll delete them. So you'll see here, instead of doing the normal thing where it would say public user add user, it says user or IUserUtility dot add user. Void IUserUtility dot delete user. So it's explicitly saying that these methods are implementing this interface. Yes? More? Sure. That good? Okay. So user, IUserUtility, add user. There's like rows in front of you that don't have people in them. You could.
Yeah, the font needs to sit from the teacher though, the cooler part.
The cooler you are? It's like the back of the bus, right?
Why do we have so many TVs? Like, do these hook up to that?
They were not here 2 weeks ago. They were here today. I have no idea.
Is that why I'm so confused? Why I'm like, why are there so many TVs?
It could be. I'm assuming they're going to hook them up so that you can see better.
Yeah.
But your guess is as good as mine. I was surprised to see them when I walked in. So, no idea. So that's an explicit implementation. In our case, we're going to do an implicit or just a standard implementation, which gives us those method bodies. So add, delete, update, and then get all. Yes?
When you did the explicit thing, and you said that like, if you had a method in your class that had the same name as the method in the interface.
Yes.
How would you get around that if you did the explicit cast? Did that mean you didn't have to implement some of those methods? Or do you still have to implement all the methods that are in the interface and the class that's using the interface no matter what, even if you do an explicit implementation?
It's the latter. You have to implement them. You either have to you have to put some sort of body inside of that method. So you do have to implement them. Now, whether you're doing a true implementation, like you're actually writing code to make it do that thing that it's supposed to do, or you just put in there an exception that says not implemented. And there actually is an exception type called not implemented.
So that's what you would do for your example
right
of
there.
when is enumerable for the for each loop. Like, from what I got from what you were saying, is like you wanted to use some of the things in the interface, but not all. Is that what you were saying?
No, what I was saying is that I want to. So what's a good example? Let me think of a good example. Now this is really shoddy code, but here's an example. Let's say for some reason, from this SQL user utility, you would want to be able to simply say for each user in SQL user utility and loop through all the users. Okay? So I have this method here called getAllUsers, right? But instead of saying, it's a lot of work for me to write userutil.getAllUsers in order to loop through this collection of users that come out of the utility. I'm just giving you an example of that. Like, that's the scenario. That's how I'm thinking about it as a developer. I want to be able to just simply write in for each user u in this. And I want that to work. This being the SQL user utility. Do you understand what that little line says? Okay. So in order to get that to work, I have to implement enumerable of user. Now the moment I do that, look, my for each loop is happy. Okay? But my compiler is sad. Because I have two members off of IEnumerable that have to be implemented. Now those two members, I'm just going to do a regular implementation of them, are getEnumerator, and then this really funky one called getEnumerator. That is a explicit implementation of system.collection.enumerable. An IEnumerable interface with the generic inherits or implements the base enumerable. So, I have to write both of these. So, I really don't want to write this getEnumerator because if you're actually using the utility the way it should be used, you should be using those methods. You should be calling getAllUsers. You should be doing whatever, that work. But for whatever reason, we want to implement this collection. We want to have this functionality exist. But I don't want to have a method called getEnumerator. Is that a fair statement? So instead of doing an implicit implementation, I'll come back here and I'll do an explicit implementation. Now, maybe I really don't want to have this functionality, so I can just leave these not implemented exceptions there. So then if I try to do a for each loop, I'll actually, when this for each loop starts to run, it'll hit this line of code and it'll blow up and say not implemented. So that would be your not implemented case, where you have a member of an interface that you don't want to deal with, you don't want to implement it. Now obviously this interface has an isolated piece of functionality that we want, so we actually need to implement it. So what it wants is it wants us to return IEnumerator of user. Now because getAllUsers returns a list, we can say return getAllUsers and the list class implements IEnumerable. So it has a getEnumerator method. There should at least be one person in this room that's impressed. So you get the idea here? So we've now enabled that functionality. Now down here, it wants me to return an enumerator. Now, if you look at this properly, you can understand that this return enumerator is inherited from system.collections.IEnumerable.getEnumerator. So I'm just going to pull up the docs. Come on. Okay. So this is the interface definition. Public interface, gotta make that bigger for you. Public interface IEnumerable out of T, don't worry about that, colon IEnumerable. So the IEnumerable generic is the way that you would describe this IEnumerable out T. That's the generic version of IEnumerable. It allows you to explicitly cast the type of this enumerable. It implements the base interface of IEnumerable. It's for backwards compatibility. It's taking the old functionality and implements it in the new functionality so that they work in both cases. That implementation gives us this line of code, or this method that we have to implement. So this is where things get a little goofy. We can simply say return get enumerator. Actually, IEnumerable user. This get enumerator. I love watching everybody's face. Everybody's face goes, what? So, what does this refer to?
The SQL utility class?
SQL utility class. SQL utility class implements what interface?
IEnumerable. Or the IEnumerator?
IEnumerable of user. So I can cast my own utility class into an IEnumerable of user. And I have to, because the only way that I can get access to this method is by dealing with a variable that is of type IEnumerable user. Let me do it in 2 lines. Actually, I'll do it in 3 lines. So this one line is the equivalent of Does that make a little more sense? I'm not getting as many scrunchy faces. Okay. Do you see how these are the same though?
I don't understand why it works.
Why it works?
The bottom one.
Okay.
I just like when I feel
Okay.
like I wouldn't type that out.
Alright.
Wouldn't it be this equals IEnum?
This equals. No.
Like,
Because I want to take my SQL user utility and put it inside of a variable that is IEnumerable of user.
okay.
So, because SQL user utility implements IEnumerable user, I don't have to explicitly cast it into an IEnumerable. The compiler knows that it's just like when you inherit from something. I could make IEnum an object, and I can put anything inside that object variable, right? Because everything inherits from object. In this case, it's not quite that broad, but SQL user utility implements IEnumerable of user, therefore I can create this variable, IEnum, and I can take this, the user utility, and store it inside of IEnum.
Okay.
Does that clarify?
Yeah.
And then, now that I'm dealing with IEnumerable of user, I can get access to the getEnumerator method and return it, which really calls the method above. Yes?
I still don't understand why we're returning a getEnumerator. Isn't the method asking for like an IEnumerator to be returned?
Yeah, and IEnumerator returns IEnumerator of user. You have to wait for Chrome. An IEnumerator of T implements IEnumerator. So because IEnumerator of T implements IEnumerator, I can return an IEnumerator of T, or an IEnumerator of user in this case, and the compiler will automatically cast it into an IEnumerator because it implements that base interface.
So when you call getEnumerator
So when I call it down here, it calls this method. This method returns IEnumerator of user, which then in return returns an IEnumerator because they inherit one another.
Yeah, how are you calling the method like inside the method where you're declaring it? Isn't that what's going on?
Here?
Yeah.
No. Get all users. That's what's going on. So get all users is calling this method up here. That method returns a list. So I then take my list of users and call getEnumerator to give me my IEnumerator of users.
But I thought what you were doing there was like telling it how getEnumerator, like I thought you were like implementing getEnumerator.
I am. I'm doing an explicit implementation.
I think the best way for me to try and explain what my confusion is like when you originally had Visual Studio build the implementations for you, like at first they were like non-implemented exceptions. So if you tried to use those methods, they wouldn't do anything, right?
Correct.
So there you're like basically building the methods from the interface, like you're building getEnumerator and the other one.
Which is also getEnumerator.
So like how come, I guess like how are you able to use those methods when you're like telling them, like building the methods?
Okay. So first of all, the methods are not dependent on themselves. I think that's really your core confusion, is that you're thinking that this call is calling this, right? Which is itself. That's not the case. This call is calling getEnumerator off of a list of user. That list of user is coming from getAllUsers, which is another method that lives up higher, which I apparently don't have implemented. Let's assume that it's implemented. Oh, because that's SQL. This is the SQL instance. Let me... All right, I'm going to scrap this for a moment. And I think the fact that this class isn't implement, like we don't even have any body statements yet, I think that's part of what's throwing you. So I'm going to move back to the XML user utility, where we actually have some meat in here, and that may help clarify what's going on. I think there's too many abstract concepts happening that's probably clouding what's going on. All right, so inside of XML user utility, we have getAllUsers, and inside of here we have our data set. We have our data table of users. I create this list of users, and then we loop through the rows in the data table, converting them into user objects. We take the user object, we add it to the list, fill the list with users, and then we return that new list object full of users, assuming that there's users in the data set. So we now have this. And for the life of me, it's too much work for me to call a method. Back here, no, I do not want you. Refresh list. This call here of getAllUsers is just too much work for me. Too much. I don't want to do that. It makes the code really hard to understand, and you have no idea what it's doing, and you're all giving me the scrunchy face. But that's what I want to do. Okay? That's the objective. So to do that, I have to implement the IEnumerable. Because if I run this right now, I might have to do something else to it first. No. It's going to yell at me. it says complex data binding accepts a data source either on iList or iList source. So it actually wants me to implement iList. It doesn't even want IEnumerable. But I'll give you a hint. iList, it implements IEnumerable. It's funny how they work. So it wants me to implement iList so that I can get this line of code to work. So to do that, and if it's not clear yet, this user util that I'm passing in as my data source is my XML user utility class. So I'm going to go back to that class, and I'm going to implement iList of user. Okay? Now, how do you want me to do it? An explicit or implicit implementation?
I'm still not really understanding the difference between the two.
All right, well then, if you don't have a preference, we'll go with explicit. So, in order for me to implement iList of user, I need to have a method that gives me the index of an item. I need to do an insert, a remove at. This is my indexing with the square brackets. Add, clear, contains, copy to, count, is read only, remove, get enumerator, and get enumerator from the base IEnumerator. So this is actually a really good example of when you would not want to probably implement everything. We can go through and implement each one of these, but I don't know if you all want to sit here and watch me write code. So, most of these, when they get auto-generated by Visual Studio, they have the not implemented exception. So let's figure out what's the minimum number of methods or routines that we have to implement. View. Outlining. Okay. So I bet the two that we're going to have to implement are the IEnumerator and the base class getEnumerator. Just my gut. Okay? So we'll start there. So getEnumerator wants us to return an IEnumerable of user. Where do we get our collection of users? What function do I call within this utility class to get my collection of users? Get all users. Okay. Actually, before we even go that far, get that out of there. All right, save, F6, good build, F5. So I'm just going to run it. So we now have that interface. We're saying that we're implementing the interface. We have all the members of the interface, but we didn't implement any of them, right? So now what's happening is we're still getting the same error. Complex data binding accepts a data source of either iList or iList source. Maybe iList is different than iList generic. So iList does not implement, or iList generic does not implement iList. So we actually have to do iList. So So we'll get rid of that. Don't need those. We'll implement that interface instead. Edit outlining. All right. So we have add, clear, contains, da 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 da. So save, F6, F5. So now we're getting a not implemented exception. It says the method or operation is not implemented. Obviously, because we didn't implement anything in our interface. If we go into view details, it'll give us our debug exception object details. So this is the not implemented exception object. Inside of this object is a property called stack trace. If you look at the stack trace, it'll actually give you just about every method call up to the point when the exception is thrown. This is the easiest way to figure out where did that error happen in my code. So if we look through here, we have the list control, set data connection, context binding, currency management, currency manager, and then on our XML user utility, line 226 is called, at which point the exception is thrown. I know it's hard to see. I apologize. So if we jump back here, we'll see, actually the breakpoint is right here, line 226. So count has to be implemented off this interface definition. So the count is the count of users, right? So to get the count of users, we need to take our list of users and return all users.count. Does that make sense to everybody? Okay, so we'll run it again. All right, so we didn't get an exception this time. It was okay. Everything was good. So we'll go ahead and say add user. All right, so now we had another error. We hit another not implemented exception. So the next line of code inside of that list box, so first it checked for a count. Are there actually any objects in this I list? It returned 0 the first time we booted up the app because there was no objects, there's no users in our list. Therefore it said fine, there's no reason to do any more work, and it went on its way. Now there's an object there. They said, okay, my guess is that it probably has a for loop internally, and it's doing for doing a for I equals 0, I, da da da. And then going through and saying, let me grab the indexer of that I list to grab the object out. So the problem is now we're at this point in the code, and we need to actually get the item at position, whatever position it is. It's probably 0, yes. So how do we do that? We have to implement this. So we can say return, and I'm going to shorthand it. So instead of declaring a variable and doing get all users, I'm just going to do get all users. Now, get all users returns that list. And maybe this is a bad scenario. List user, all users, get all users, and then return all users with the index. What I was going to write was then you got parentheses and square brackets next to each other, and it looks kind of weird. Again, these do the same thing. So instead, for me, instead of writing 2 lines of code, it's easier just to write the 1 line. But you see how they fit together? So this now returns the object in that position. And there's our user. So in order for us to be able to write this 1 line of code the way that I chose to write it, list users.data source equals user util, we had to implement the iList interface. Actually, we went through trial and error and figured out which members of that interface are being used, and then went through and actually implemented just those members. We didn't write everything else. We didn't do all the other work. But if we look at our user utility, now we have all of these additional functions because we implemented iList.
But the only ones that will work are the ones that we implement, like we actually wrote code for.
Correct. The rest of them will throw a not implemented exception. Now we've gunked up our code by implementing that interface implicitly. We actually added members to our class and they show up here. If we wanted to do it explicitly, because it's only those 2 members, I'm going to go ahead and delete all these. If we choose to implement this explicitly, we end up with these types of function definitions. So int system collections ilist.add. That's the explicit implementation of iList. So the 2 we have to do are count and this. So here it's the same thing. I'm just going to do the shorthand. It's that one. And return get all users dot count. Let me rebuild. Okay. So now we have fewer methods. We don't have that big collection of all those additional members that we had before. We get a few of them, and that's because of a feature inside of C#4 called extensions. I'm not going to go there. So, if you're curious, you can look it up. If you want me to talk about it another week, ask the question, and I'll talk about it another week. But we've greatly decreased the number of methods that we have here to just be really that core set of methods that we're wanting to use. So that's the inherent difference between implicit and explicit is, do you want those members to be publicly available without forcibly casting your class into that type? And by forcibly casting, that's when we use the parentheses with the type name, and then we use the variable. That's called an explicit cast. You're explicitly telling the compiler, take this type and change it into this type. And by doing that and actually making the variable I, in this case, iList, you never see those members. But you can convert it into an iList. Just like you can take any variable and convert it into an object. Same idea. But because we implemented that interface, we have the special right to take that and implement it or convert it into that other interface.